Today we're going to solve a system of equations algebraically using elimination. You may need to multiply one or both equations by a constant so that one of the variables has the opposite coefficient in one equation as it has in the other. And remember that by opposite coefficient, what I'm looking for is for one coefficient to be positive and one to be negative. And the reason that I need this is so that when I solve these equations and I add the two equations together, one of the variables will be eliminated. Okay? So for our first example, we're asked to solve 2x minus 4y equals negative 26 and 3x minus y equals negative 24. And so the first thing I want to do is I want to stop and take a look at this equation. And I notice that if I'm paying attention to the y variables, that I have a negative 4y in one equation and a negative y in the other equation. And so if I just go through and multiply the second equation by negative 4, I can turn this negative y into a positive 4y, and that will allow me to add those equations together and eliminate the y's. So I'm going to leave the top equation alone, and I'm going to go through and multiply the bottom equation by negative 4. So I get negative 12x plus a positive 4y equals a positive 96. Then I want to add those two equations together. And the y's will cancel. They'll be eliminated. I'm left with negative 10x equals 70. And now I can solve this equation for x. So I want to divide both sides by negative 10. And I get x equals negative 7. And so now I want to take this answer that I've found for x, and I want to plug it into one of the two original equations. And so I'm going to choose the first equation for no other reason than it was first. And I want to plug in the negative 7 where x was and finish writing out the equation. So negative 2 times negative 7 is negative 14 minus 4y equals negative 26. I want to add 14 to both sides. I get negative 4y equals negative 12. Divide both sides by negative 4. And I find that y is equal to 3. And so now I want to present the solution as an ordered pair. And so the solution to this system of equations is x equals negative 7, y equals 3. Any questions? So for this next example, we're asked to solve the system 4x minus y equals 6 and 2x minus y over 2 equals 4. And so as you begin to look at this equation, and I always like to stop and look at it and try to figure out which variable is the easiest variable to eliminate, the first thing that I might notice is that if I were to multiply both sides here by negative 2, I could make the x's cancel out. Or you might have noticed if I multiply the second equation by negative 2, the y's might cancel out. And that might lead you to think about something that we've discussed before. But let's go ahead and begin to solve this. And while we're solving it, I want you to think about some of the solutions that we can get when we solve simultaneous equations or a system of equations, okay? And so we're going to go ahead and multiply through, and my goal is going to be to, in my brain, eliminate the x's. So I have 4x minus y equals 6. And so now I want to multiply the second equation by negative 2. And so I get negative 4x. And then I come over and I say negative 2 times negative y over 2 is positive y. And negative 2 times 4 is negative 8. Okay? And so now I want to do what I've done before. I want to add these equations together. And so the x's canceled because that's what I was going for. But look here, I have negative y plus y, so those also cancel. So there's nothing left on this side of the equation. And 6 plus negative 8 is negative 2. And so now I end up with an equation that says 0 is equal to negative 2, which we know is not possible. Therefore, this system of equations has no solutions, or I can use the empty set. Hopefully you remember that before we started solving a system of equations algebraically, that there were in fact 3 possible outcomes for a system. We could have a solution, which gave us, if we had 2 equations, a set of ordered pairs. If we have 3 equations, a set of ordered triplets. We could have no solutions, or we could have an infinite number of solutions. And so you always have to keep that in your mind as you're solving these equations. Okay, our next example is asking us to solve 3x minus 2y equals 4 and 5x plus 3y equals negative 25. And so again, I always like to stop and look, and doesn't look like I can just multiply one equation by a number to eliminate a variable. So it looks like I'm going to have to multiply both equations, and sometimes you do. And so again, at this point, you have to make a choice as to which variable you're going to eliminate. And when I am eliminating variables, I just have a tendency to do the one that appears to be the easiest. And I notice that the y's already have a positive and a negative, so I'm just going to decide to eliminate the y variables. So I want to think about what is the least common multiple between 2 and 3, and that would be 6. And so I'm going to multiply both equations by the specific number that will give me a 6y in each equation. And so I want to multiply the top equation by 3 and the bottom equation by 2. And so that gives me 9x minus 6y equals 12, and 10x plus 6y equals negative 50. And I am now going to add these 2 equations together, just as I've done before, to eliminate the y variables. So I get 19x equals negative 38. And I want to divide both sides by 19. And x equals negative 2. And so again, I want to do the same thing that I did in the first example. I want to take this x equals 2 and I want to plug it into one of the 2 original equations. And this time, just to be different, I'm going to plug it into the second equation. So I get 5 times negative 2 plus 3y equals negative 25. And that gives me negative 10 plus 3y equals negative 25. I want to add 10 to both sides of the equation. And 3y equals negative 15. Divide by 3. And y equals negative 5. So now I have a unique solution, and remember the way you want to present it. You want to present it as a set of ordered pairs. So the solution is negative 2, comma, negative 5. Okay. For our next example, we're asked to solve the system of equations 2x plus y equals 8 and 3x plus 3y over 2 equals 12. And of course, you can think about which variable you want to eliminate. Again, I'm kind of lazy, and so I like to eliminate the variable that is the easiest. And so if I start to think about trying to get rid of the x's, I think, oh, I've got to multiply both equations. And that's probably not the easiest. So what I want to do is I want to multiply the top equation by -3/2. And yes, that is the easiest. So we start here and we begin to multiply. And so -3/2 times 2x, the 2's will cancel and we get -3x, right? Then we get -3y over 2. And then we come over here and when we multiply -3 times 8, 2 will go into 8 4 times. 4 times -3 is -12. And then we write down the second equation. And we add to eliminate. And if you start to look at this, -3x and +3x, that eliminates. -3y over 2 and +3y over 2, that adds up to 0. They eliminate. So there's a 0 on this side. And over here we have -12 plus +12, which is also 0. So we end up with a true statement, 0 equals 0, and therefore this system of equations has an infinite number of solutions. Okay, so now it's time for you to practice. Thank you.